In this lesson, we will design a set of roll tools to reshape a closed or welded tubular section. In our previous lessons, we defined open profiles where the upper and lower, and sometimes side rolls, need only create parallel paths between roll faces to bend metal to the desired shape. In welded tube production, we encounter a different set of processes where we are combining bending and compression of sections or the entire cross-section to create a new desired shape. In order to completely surround the closed section, as in sizing a round welded tube, the driven roll contours are created in the same way as tools for roll form sections, except where the outer flanges of the tools meet one another. Here we will use another feature of profile design to create flange gaps between the roll tool faces. Flange gap widths are generally based on a percentage of the thinnest gauge one anticipates the design to function with. If the material is low strength and the gap is too large, the material may extrude into the gap. With higher strength materials, the gap may be increased without creating a problem in forming. For example, a 1.5 millimeter wall by 78 millimeter OD medium strength steel tube flange gap could be 1.25 times the wall thickness, or 2.25 millimeter without extruding material into the gap. The flange gap provides the machine operator adjustment capability to accommodate wear in the roll tool root diameter, or in an increase in material yield strength where additional compression of the section is needed to create the desired dimension when the section exits the driven stands. In this lesson, I want to show you how to design round and shaped tubes and to create roll tools for this process. In this example, I will make a roll tool design for a rectangular tube. I prepared the final cross-section by using the toolbox profile design, C profile, and I entered dimensions 20 and 30 millimeter. The sheet thickness should be 1 millimeter. I prepared a machine with 3 calibration stands. F01 is the welding station for the round tube, and F02 until F04 are the fin passes. Then comes the breakdown passes. How the machine is set up, shown in another video. First, I will create the calibration passes. A welded round tube should be formed to the desired rectangular tube. I call calculate shaped tubes calibration, and I am asked if this rectangular tube should be formed from a round or an elliptical tube, or if the cross-section should remain unchanged. This means only the dimensions become smaller. I select from a round tube, and then the calibration passes are created. The last one is the round tube of the welded pass. Have a look on the strip width in the different passes. It becomes smaller from pass to pass because the calibration process works with high pressure in order to create a tube with high dimension qualities. In the machine data, this is set up by the calibration factor. Here also, a different deformation degree can be set up for each calibration stand. In this example, this causes a smaller deformation in the final stand. Next step is to create the fin passes and the breakdown passes. This can be done by using the toolbox tube design manually. If special requirements are necessary, or automatically. I will show the automatic creation. I select the welding pass with a round tube, and I call Calculate Round Tube Forming. Now I am asked how many fin passes are required. I select 3. Then all passes are created automatically against the sheet running direction down to the flat strip. This image is bottom line forming. In tube forming industry, center line forming is very common. This is why the band edges of the tubes take long routes between the passes. This leads to high longitudinal stress. Centerline forming decreases the stress. I call Profile Centerline Forming and enter 100%. Then all passes have the same centroid, the center of the tube. I check the stress of band edge. It is okay. All bars are below the yield stress. If I want, I can use the toolbox tube design to optimize the flower pattern. I can modify a certain entry by using the page up, down buttons on the keyboard, and I see the result in the bar diagram simultaneously. Next step is to create the roll tools. I switch to Roll Tool View, and in the toolbox, I call Breakdown Pass Bottom Roll. Now I open Breakdown Pass Top Roll. And the rolls for this stand are ready. I continue with the next pass. Here I want to enter side rolls. The diameter is too small, so I modify it by using the page up-down buttons on the keyboard. The same with the shoulder. And also the rolls for this stand are ready. The next breakdown stand gets bottom and top rolls again. It is very common to use top, bottom, and side rolls alternately. And here again, side rolls. If the values in the input field are too large, don't worry. They are shortened to the maximum value. L09. And here again, top and bottom rolls. Here again, side rolls. And this, now the first fin pass. So I use the function for the fin pass from the toolbox. The second fin pass, and the third. LO4, this is the welding station. It gets side rolls. Now comes the calibration stands. Create a trick. I switch to pass view, and I split the arcs in two halves. Why? I will show it later. LO2, the same in this calibration stand. I enter half of the bending angle. And the same in the final calibration stand. Also here, half of the angle. Now I switch back to the first calibration stand. And I create a bottom roll by scanning the profile contour. Here you see the reason why I split the arcs. Need cylindrical extensions on both sides. Now the top roll also by scanning. Also here we create the cylindrical extensions. Side rolls by scanning. And I mirror the roll from the right to the left side. Now I do the same thing with a second calibration stand. Creating the contour by scanning. and the side rules by scanning. And the final calibration stand, as the two previous were created. The trick of splitting the bend radius makes this easy. The roll tool design for a shaped and round tube is ready. This was an example only. You can adapt the design to your individual needs and to any tube forming machine.